I'm going to share my screen out to Canvas. I'm in student mode, so it should look pretty much identical to what you see when you open your environment. Make sure my chat is open. And just kind of walking through this format again, at the very top of the page, you have the link to the virtual classroom. That's the Zoom room that we are in currently. There's also a link to this virtual classroom bookmark to the top of the Canvas page. So you can find it at either place. But if you're here, you're aware of at least one of those formats. There is a little bit of prerequisite information, review information. If you want to go back and review this, by all means, please do so. And this Vocarium machine section is where we'll be storing these virtual machines that operate in the cloud. So these are fully functional virtual computers that we'll be booting up and interacting with through our web browser. This sort of eliminates the idea for us to have to deal with everybody's different hardware and setting up home labs. But by all means, if you're interested in setting up your own locally hosted hypervisor and virtual machines, anyone on the instructional team can help you on one of these lab days to potentially get that up and running. With that being said, there's two virtual machines here that are named similarly. They're very different. This first Unit 2 Linux machine is an Ubuntu Linux machine. That's just a particular flavor of Linux. Linux is an open source operating system. So it is openly available and free to download. There's a lot of different providers that are giving different versions of Linux that serve different purposes for different people. But this is an Ubuntu-based machine where we'll be doing most of our cohort connection work and a portion of your workshop work. Some of your workshop work will particularly be based on some capture the flag exercises, and that will be using this second Linux CyberLab machine. This is a Mint machine rather than an Ubuntu machine. They are very similar. They operate almost exactly the same, but they do have different resources. So any of the flags that you're looking for that would be hidden in this machine for your capture the flag exercises will not be in this machine. And any of the resources that it asks you to start up within this machine are not going to be found in this machine. They're mutually exclusive in that way. So being aware of which machine you should be working in is a detail that we have to pay attention to. After lunch, we'll talk a little bit about the second machine and what your workshops look like and where to keep your eyes on to make sure that we are operating in the correct environment. They're similar, but they're very different. With that being said, the Linux machine is the one that we'll be working in for the cohort connection and for the demonstrations this morning. So if you click this Linux lab, it's going to ask you to open this machine in a new window. And you should not see this window. It should pop you straight into the first time a window that's going to offer or ask you to accept the terms, the agreement terms. Just go ahead and fire that up. And you should see a V start spinning. I think I should be able to get to it this way quickly. I have a machine already running, but well, let's just pause there. And is everyone able to give me a thumbs up on the screen or via reaction if you're able to accept those terms and you see a V spinning like the wheel of destiny? See a couple. See one in the chat. Okay, let's take the other approach and unmute and make any noise in the world if you're not able to get that V spinning.
I'm unsure. I'm still working on it.
Okay, no problem.
How do I do it again?
Let me share my screen again. Within your Canvas environment, there should be a modules section that'll give you basically all of the modules that are broken down, and we'll continue to release these. But at the top, below Virtual Classroom and below Pre-Access, there's a section called Vocarium Machines. And we want to click this Unit 2 Linux machine. It'll open in a new window, and it's going to ask you to accept terms of agreement. Once you accept those terms of agreement, you should see a V that's spinning. You may have to click Start Lab, a blue button that says Start Lab in a gray box.
Okay, I have the spinning V.
Cool. Corey, how about you?
Okay, I got it. Thank you so much.
No problem. This is something we'll be doing every single morning, and something that is pivotal to every single section that we're going to be working on is getting these virtual machines open. So it's key that we're all there. Last call for anybody who's not spinning. Alexi, once we break into breakout rooms today, we'll make sure that one of us visits you or pulls you aside, and we'll see if we can get that kink worked out.
After the spinning thing, is it supposed to say launch lab?
If it says launch lab, click that button.
Oh, okay. Oh, I see it now. Yeah.
And it'll probably keep spinning on you.
Yeah. All right. Thank you.
Yeah, no problem. So while that boots up, let's take a look at a basic idea of the most 10,000 foot view of what this environment looks like, because the big takeaway for today is going to be understanding the structure of this environment. Where are we? How is this constructed? And how can I orient myself and navigate myself throughout this file system? There's really two different major types of files that we're going to be talking about today. And Linux is an interesting operating system in that everything within the Linux environment is a file of some type. That's not something we need to concern ourselves with insanely today, but it's just something to keep in mind. And the two major types of file types that we'll be talking about today are files and directories. And when we think about a file, you can think about a file the same way that you would in your host-based operating system, whether that's an iOS, Unix-based operating system, or you're on a Windows machine. We understand what a file is, right? And the other type of file that we'll be talking about is a directory, which is essentially a folder. And I might call it a folder a couple times so that we make sure we understand what this directory is and how it's working, but I'm not going to call it a folder. In Linux, we call these directories. But for all intents and purposes, these files we can think of as sheets of paper, and these directories we can think of as a folder. And that's the way that this whole operating system is set up, right? I could put a sheet of paper inside of a folder, and I could put a folder inside of a folder, but I can't put a folder inside of a sheet of paper or a sheet of paper inside of another sheet of paper, right? So if we think about how this might actually look, we can think of the idea of having one big giant folder, right? Pardon my lack of artistic expertise, but think of this as one open big folder. And I could put a sheet of paper inside that folder. I could put multiple sheets of paper inside of that folder. And I could even put a folder inside of this folder, right? And I could put paper inside of that folder. And I could put another folder inside of that folder. And I could continue this down the line until eventually I have a big stack of folders, right? It's one thick folder that's full of folders and papers. And that is our Linux file system. This very outside folder, in other words, the folder that every other file and folder is inside of, is called our root directory. everything starts at root, right? There's nothing within our environment that isn't inside of that outside taco shell. This root directory holds everything, which means that we can always identify any particular file or directory's location based on directions from root. So a very simple file system might look something like this. We have our root directory that holds everything else. And inside of that root directory, we might have a couple other directories. And inside of those directories, we can have more directories and maybe even a file or two. And those directories can also have other directories in them, which can have files in them. Or maybe we have an empty directory. Now let's think about something for a second. What makes each of these directories or files unique is its location within this entire file system. I have a file here called 1, and there's another file here called 1, and there's another file here called 1. They're not the same one. Their difference is the location, their location within this file system. And the most straightforward way that I can get to that location is its relationship to this root directory. So if I'm referring to specifically this directory, I can identify it by saying it's the directory called 1 or the file called 1, but specifically the file called 1 that's inside of the directory called A, that's inside of the directory called root. Whereas this one is the file 1 that's inside of the directory called F, that's inside of the directory called C, that's inside of the directory called A, that's inside of the directory called root. And this one is the one that's inside of a directory called E, that's inside a directory called B, that's inside of a directory called root. If I try to create another file within this directory, this E directory, and I called it 1, the operating system is going to tell me you already have a file called 1. I can't create that file. You can create a 1 in any other directory, but there's already a 1 at that address. In other words, if I already live in apartment 12, no one else can live at my address at apartment 12. By all means, live in apartment 12 at the address next door, but there's only one apartment 12 in this building, right? There's only one file 1 within this directory. We were working directions backwards. Normally, we'll give directions to where we want to go from where you are, right? If we consider root the beginning point of any directions, then I can give directions to this to file by saying go to A, then go to C, then go to F, and inside of F, you'll find 2. And anybody who's within this environment can follow those directions exactly and locate that file. Does that make sense to everybody? Are there any questions or confusions about that sort of simple concept of directories and files all nested into each other, and the idea of this root directory being the trunk of this tree, right? It branches out. You can think about it as a root system or as a branching system. There's an end to every single path, right? But every path begins at root. I think that orienting ourselves this way is going to make it a lot easier when we dive into this command line to sort of understand what's going on there. Make a noise or raise your hand if your V is still spinning. And if your V is not spinning, what do you see?
I think I'm on the Linux like operating system right now. It's like showing me a background and stuff.
Cool. It should be a puma, panther, jaguar, cat, some type of cat with laser beams shooting out of its eyes. Everybody seen something like this? Cool. So this is absolutely the operating system. This is the graphical user interface. This is the desktop, right? Something I want to point out is within this particular Linux environment within Vocarium, we have one machine. It's this Ubuntu machine. We will be operating in Vocarium environments that might have 2, 3, or 4 machines all operating within that environment, and we can click each of these machines to open them. They'll open in a window that's slightly different. Something that looks like this. And notice the difference between these two tabs. They're almost identical, but they are different. The one that's listed, Vocarium Workbench, is sort of your control area, right? This is where system controls are, like these here. And within these DCV windows, none of those options are here. You can do any actions in either of these windows. But keep in mind that if you do need to open other machines, you can. And these controls are controlling the functions of this machine that we're using. So a few of these that I really want to point out to you are the Start Lab button, that if you don't see it within here to start up, we can always start our lab using this button here. These labs are going to run for about 3 hours. This is a paid service in the cloud that Full Stack is taking care of. So we don't want these machines running indefinitely. So they'll run for about 3 hours before it'll shut down and you'll have to re-click that Canvas link. Unless you hit this extend button, which will extend your lab time a little bit longer. So I would recommend clicking this extend lab button every couple hours if we're going to be in class using this machine all day. I'd also recommend shutting these machines down for lunch and booting it back up when you come back from lunch. Sometimes that can be another helpful way to sort of mitigate having the system shut you down in the middle of while you're doing something. With that being said, if you come back and open the machine, whatever files and directories you've created should still be there for you. These virtual machines are virtual for a reason. Do not be afraid to experiment, to click enter, to do anything that may break the system, right? They are intended to be burnt to the ground and built right back up. You can always click this reset button, and that's basically going to take this machine back to factory settings and back to how it is right now when you just booted it up. All the exercises that we're going to be doing in the labs are independently built in. So we can boot up any of those labs at any time. There's no need to recover any of those resources. We can always just fire them up in the cloud. So feel confident in making whatever moves you want on this machine to learn. You're not going to break it. And if you do break it, we'll just spin it right back up. That's one of the beauties of virtual machines. There's an activities button here at the top that we can kind of think about as like a start menu. It gives us options here on what we can do. This is going to be one of the only times that you see me do this, but I'm going to open this file browser, which is the GUI interface to this particular file system. And it doesn't look like anything wild. It looks like something that we've probably seen on our Windows machines or on our Unix machines. But there's a bunch of directories here, and I'm in my user's home directory. There are directories behind me. If I go to this other locations, I can see that there is the computer here. And if we take a good look, it says that here's the computer, everything that's on the computer, and it's located at this slash, which is the representation for that root directory or the beginning of every single file path. is that slash. So if I click in here, this is every directory that's inside of that root directory. This is that second level. And we'll get into what a lot of these directories are. For today, I really want to just really concern ourselves with this home directory. We may talk about one more of these directories when we talk about the workshop, just to introduce it to you. But this home directory within the root directory holds the home directory for every regular user. My user is called fstack. So I have a home directory here. And inside of here, you'd see a lot of things that you'd expect within a home directory: downloads, my desktop, my documents. There's a bunch of folders here. And there's a particular file here called sample.sh. But this is the contents of my home directory. I'm going to open up on activities here. I'm going to open up this terminal. And when I say GUI, I mean GUI, graphical user interface, right? Pictures that we can use our mouse, we can drag, we can drop, we can click, we can highlight. This is how a lot of regular users are used to interacting with the computer. We are cybersecurity professionals, and that's not how we're going to do it. We're going to interact via this terminal. This is a terminal emulator, meaning it's not a physical terminal. You used to need a physical terminal that had some output and input to interact with the actual computer itself. Rather than using our mouse to navigate this graphical user interface, we're going to use this terminal emulator to operate the command line interface, or basically a text-based interface to interact with the computer or the kernel. The interface within this terminal, the terminal is this window itself, the structure of where we're operating. What we're doing within the terminal is managing or operating within the shell. The shell wraps around the kernel, and the kernel is the computer itself. So this is sort of our interface, right? There's stuff that we can type in here that humans understand, that we can directly communicate with the computer via this language, this bash shell or bash language that we're going to be using. I'm going to zoom in a little bit so that we can see a little bit better. As soon as you enter this command line interface, you'll see something called a prompt. And there's a lot of valuable information here in this prompt. The very first thing that you see on the left side of this @ symbol is the current user, your username. So I am the user fstack. And on the right side of this @ is the host name, or the name of the machine or computer that I'm on. So I am fstack and I'm on the Ubuntu machine. If another user logs into the same machine, they may be a different username at this same machine. And eventually we'll learn how to interact with other machines via our command line, in which case we would see this host name change. There's a separator colon, and then there's this squiggly tilde. This is a shortcut for our user's home directory, which is by default where we start up, right? As soon as I opened up that file browser interface, it also, by default, opened up right in my home directory. Same rules apply. I'm right in my home directory here. And this $sign is saying that I'm a regular bash user. There will be times that you may see this change to a different symbol, maybe an octothorpe or a hash. That's a representation that you're not necessarily a regular user. But for now, we can just consider this representing that we are in a bash shell, or we're going to interact with this terminal using bash as a language. So how can I prove this stuff, or what other ways can I identify who I am, what machine I'm on, or what directory I'm in? And we said that this is a shortcut for my home directory. Anytime you see a // that is a shortcut representation for our root directory. Anytime you see a squiggly tilde, that is a shortcut for the current user's home directory, right? So our first commands that we can kind of learn here are, one is, who am I? One word, who am I? And that's basically asking, what user am I currently logged in as? And it tells me that I'm FStack. It exactly matches the prompt telling me what my username is. If I want to know this host name or the name of the machine, I can call host name and hit enter. And it gives me as output, my input is host name. My output, the standard output, says Ubuntu or the name of this particular host. The last one that we'll look at is determining where our current directory is. Where am I, right? If we're going to be navigating this file system, something that I need to know is where I am. If I'm going to try to get to anywhere else, I need to first know where I am. And this is kind of our you are here. When you're at a mall and you see the map and there's a sticker that says you are here, if we want to know where we are, we can use the command pwd, which stands for present working directory. Which folder or which directory am I in at this moment right now? And it tells me that I'm in home FStack. And there's this leading slash, which is the actual root directory itself. So that means within the root directory, there's a file called home, or a directory called home. And within that directory called home, there's a directory called FStack where I currently am. If we come here, we could take that same approach, right? I could say, here's my root directory. Inside of this root directory, there's a directory called home that has everybody's home directories. And inside of the home directory, there's a directory called FStack that is my home directory. And there are things in here, desktop, documents, downloads, right? The command ls is going to list your present working directory if we don't give it any other options, right? I can list other directories, but by default, if I just type ls, it's going to tell me what is inside of this directory, the directory that I'm currently in. And we can see a lot of correlation here, right? Desktop, documents, downloads, music, pictures. Desktop documents, download, music, pictures. Sample.sh file. Here's that sample.sh file. There's some color-coded differences here that our terminal is thoughtfully displaying for us. It's not always the case that our output will be color-coded in such a way, but this sort of gives us an idea of what we're looking at and what may be different than other things. By default, within this particular system, anything that's listed in blue is a directory. So within the root directory, there's a directory called home. Inside home, there's FStack, and inside FStack, there's all of these different directories. So what if I want to visit another one of these directories? In the GUI, I double-click that folder, and it opens up for me. Within the command line, we need to change our current directory to that directory. And cd is the command to change directories. And I'm going to change my directory to this particular demo1 directory. So I'm just going to type cd demo1. Linux is case sensitive. So a capital D is not going to work for me here. I need to exactly match the syntax of this directory. But if I cd to demo1, my prompt changes to tell me now you're in the demo1 folder within your home directory, your current user's home directory. And if I print my working directory again, I can see that I'm now in the directory called demo1, that's inside of the directory called full stack, that's inside of the directory called home, that's inside of the directory called root. This is my absolute path, those directions to the directory that I'm in. I'm starting to get a little congested here. I'm losing real estate. Let's introduce a command called clear. And clear is going to do exactly what it sounds like it does. It's going to clean my room. I'm still in my demo1 directory. Nothing's changed. I wiped the whiteboard. I'm going to ls within this directory. And we can see that there's all sorts of different colors, right? We're not going to concern ourselves with what each of these different file types is today. We're going to get into that throughout the scope of the course. But I want us to identify that there are different colors here that are representing different file types. What if I want to know a little bit more information about these particular files? Well, I can add a option or a tag or a switch to my ls command. These will generally start with a dash and have a character or multiple characters. Space separating within the command line is always representative of something important. Some commands will take multiple arguments. Some will only take one. Sometimes we don't need an argument at all. But what this ls-l is going to do is, unlike just listing the contents of the directory, it's going to do a long listing of the directory contents, which is going to give me a little bit of metadata about these files or information about these particular files. Again, we're not going to worry too much about what all of this means today. We just want to understand that it's here. For the most part, this is permissions of the file, and we'll get into how that works at another time. This is how many files are within this particular directory or file. These are all files, so there's only one here. This is the owner of the file. This is the group to which the file belongs to. This is the size of the file, and this is the last date that that file was touched or interacted with. Spelling is key. You'll see me misspell clear a million times by the time we finish this boot camp. It's just a part of my life. But we've covered a couple commands here so far, right? We covered our who am I command that tells us our current user, who am I. We covered the host name command that tells us the current host is, the current machine name. We've talked about PWD or print working directory or present working directory that tells us where we are at any given time. And we talked about ls that can list the contents of a directory. So that's all fine and dandy, right? We know that if we're in a directory that we can use ls to show us what's in that directory, and we can cd. For instance, if I'm in A, I can cd space C, and that will move me to C. From there, I can ls, and I can see that there's F and G, and I can cd to F. I can ls and F, and it would tell me that there's file 1 and 2. And that's all cool. We can move forward, but where do I go from here? If I'm navigating the file system, I need to be able to go forwards. I also need to be able to jump backwards, right? If I want to get to this 2 folder, and I'm currently in F, and I want to get to this 2 file, I'll have to navigate my way over there. I can't just move directly. I'll have to get to C, to get to A, to get to root, to get to B, to get to E, to get to 1. I can do that by giving a whole list of directions or a path. But for now, I think the most straightforward way to do this is to jump and find our way there, right? So in order to move backwards within the file system, I'm going to clear this out and I'm going to hit present working directory so we can see our current path. I'm going to use CD and I'm going to use ... is a shortcut or a alias or a nickname for whichever directory is right above us, or our parent directory. In other words, if I'm in G, ... refers to C. If I'm in this D, ... refers to A. If I'm in A, ... refers to root. But it's the parent directory or the folder with which our current folder is in. So we'll see what happens when I CD to ... it backs me right back up to my home directory. I went from demo1 to fstack. And if I CD ... again, it'll back me up from fstack to the home directory within root. If I pwd here, I can see that I'm in the home directory. And if I CD ... from here, guess where I am? I'm in the root of roots. When I say, where am I? I'm at the very beginning of the road. I can do this all day long at this point. There's nowhere for me to go. My back's against the wall. I can't back up any further than this. But what I can do is move forward. So if I see what's in this root directory, these are all the files that we saw when we clicked computer, or all the directories that we saw when we clicked computer. And we said that home directory has every user's home directory. So I can CD to home. And now I'm in that home directory. And if I see what's in my home directory, I see every user that has a home directory. I am fstack, as proven by my prompt and my whoami command, which means that I can CD to fstack. And now I am within my own home directory represented by the tilde. And that directory is home fstack. Pause for a second. And if anybody wants to unmute or throw in the chat, any questions about those simple navigational commands? We can CD to a particular directory name to go directly to that child directory or the directory that's in our folder, or we can CD ... to move backwards. And there are shortcuts and faster ways to do this, but this gives us everything that we need to know to navigate this particular file system. Let's talk about the $ means that I am particularly using a bash shell. I think I can call which $shell.
And I see where you're going further, Ryan. You will do $capital shell, but in this case, the $ is showing that you are not a super user. So you're just a standard user.
And we'll get into what those super users look like. I'll just show you here. There is a user called root that's on this machine. This is like the administrative user. This is not something that you generally want to do as a security concern, is to operate as root. But notice that this prompt has changed. It's not a tilde anymore because I'm not in my own home directory. Root's home directory is not /home/fstack. So it's telling me that now I'm root at Ubuntu. This is still my file path, but notice that $ has changed to this octothorpe or this hash. That is basically the inverse of seeing that $ and knowing that you're not a regular user. You are logged in as an administrative account.
Yep, hashtag there means the safety's off.
I have a question. Do you mind showing us one of the shortcuts? I know like as a beginner, we're not going to use that, but I'm just curious to see what one of the shortcuts look like.
Yeah, we'll get there again by the end of the day. But like I said, we can give any particular directions via this file path. So to keep it really simple, if I cd to ... and then I cd to ... again, now I'm in root. And if I want to get to home fstack from root, I know that I'm in root. I have to get to home first, then I have to get to fstack. So what I can do is cd to home/fstack, and that will take me directly to home fstack without having to go to home and then go to fstack. Another thing that I could do is if I cd to demo1, I could use the same sort of relative path to go somewhere else too. I could say cd to the parent directory, which is my home directory, and then the directory here that is into the actual directory home. And then maybe I can go to a different user's home directory like Shaggy. I don't think Shaggy is a user, but this is a good moment to say, if you mistype something, you can revisit your command history by hitting the up key. And these are all the most recent commands that I've run. I think that the user I'm looking for is Scrappy. And now we can see that, let's actually go back to home. CD without an option will take you home. You can also CD to that tilde, and that will always take you from wherever you are to home. But from here, I'm going to go back to demo1. I'm going to clear this out, and I'm going to print my working directory so we can see this file path. And if I go back to what I just did, I'm sort of navigating all over the file path, and I don't want to confuse anybody. We don't have to do things this way right away. But what I did is in one command, I backed up into fstack, and then I backed up into home, and then I went back into another directory called Scrappy. That's Scrappy's home directory. And again, at any time, I can cd to this tilde, and that will take me right back home. There was a question too about the dots. When it comes to dots, these are just sort of calls to directories relative to yourself. A single dot is going to always represent the current directory that we are actually in right here. Right? It's like a bullseye right here. Wherever I currently am is a single dot. A ... is the directory above me, my parent directory. So I can call my current directory with a dot. I can call the directory above me or behind me, my parent directory, a ... and any directory in front of me, I'd have to identify by name. So I can cd to ... which is not going to do anything. It'll just take me to where I am. I could cd to ... which will back me up a directory. Or I can move forward by calling the directory. I can cd into pictures. Notice what I just did there. cd to PIC, and I hit my tab key, and it auto-completes pictures for me. There's only one directory within this directory that starts with PIC, and it's pictures. This tab auto-completion is something that I really recommend you get used to. It serves multiple purposes. First, misspellings are unaccounted for, right? I am a serial mistyper. That tab auto-completion helps to make sure that I'm not including typos. It makes my life a lot faster. And it also gives me peace of mind. If I'm going somewhere, if I cd to my root and I want to try to get to a particular directory, I can cd to ho tab, fs tab, and I'm getting these file paths to come together a lot faster. And I'm getting confirmation because that tab autocomplete is functional, that I'm on the right place. I'm actually going somewhere that does exist. Whereas if I just start typing out cd/home/f stack, and maybe I misspell something here, I'm not going to know until I finish the command, and then I'm going to hit enter, and I'm going to get an error message, and I'm going to say, oh, I misspelled stack. It's a lot easier to rely on the computer to autocomplete those things for you. And that tab key is exactly the way that we want to do that. So we talked about looking at directories and files. We talked about moving through these directories and listing what files or directories are in those directories. Let's talk a little bit about making directories or making files. I'm in my home directory, right? pwd, I'm in /home/fstack. Again, to recap, within the root directory, there's a directory called home, and this home directory in root holds every user's home directory. And by default, those home directories are listed as the name of the user. So fstack is the user fstack's home address. I'm just going to clear this out in ls again, and we can see here's what's currently in this directory. I'm going to make a new directory, and the command to make a directory is mkdir, make dir. It takes one option, and that's the name of the directory that I want to create, or the name of the directories that I want to create. I can space separate multiple, and I'll create more than one directory. But I'm going to make a directory. I'm going to call it creations. This is what we're doing, right? We're making directories and files. I'm going to call this creations. And when I hit enter, it doesn't tell me anything. And this is very much the means of communication and the style that Linux operates with. If you don't see anything, you can assume that things went correct. Linux is only going to speak up if there's an error. Otherwise, it's going to stay quiet. So I ran make directory creations, and I didn't see any prompt or any output. How can I check to see if that directory was created? Elizabeth's on it. I can use ls to list the contents of that directory again, and we can see that creations now exist when it didn't. So I can cd to creations, and that will take me to my new directory. If I look at where I am now, I'm in creations within my home directory. I'm going to list the contents of this creations directory. What's in here? Mitchell and Jordan say nothing. Nothing. Let's make another directory within my creations directory, and I'm going to call this directory movies. If I ls now, I do have a directory called movies. Let's cd into movies. And if I list the directory contents, there's nothing here. If I look at where I am, I've gone from creation to movies. So far, so good. So mkdir is going to make particular directories, whatever directory name I give it. I'm going to cd ... And let's make another directory. Let's call this one books. Now with in creations, I have books and I have movies. I can also make a directory called shows. Now I have 3 directories. So let's cd into movies. And let's make some files. Remember that directories are these sort of folders that can hold other directories. And a file is just a general file. We can have different types of file types, but we said that our directories can be related to folders and our files can be related to a single sheet of paper. And there's a lot of different ways that we can create files, but for today, we're going to look at the touch command. And touch is going to, if we give it a file name that doesn't exist, it's going to create an empty file, essentially. Touch is useful for more than that. We can use touch to, remember when we looked at the metadata about a file, ls. So ls we know can list the contents of a current directory. I can also feed it a file path or something. If I say ls, my home directory, it's not going to show me what's in my current directory. It's going to show me what's in the directory I'm pointing it towards. So we can add options to ls to list things that aren't necessarily in our current directory as well. But I'm going to run this long listing again on my home directory. And we said that this was the last date that the file was touched, right? So this says August, desktop was last touched August 31st, 2022. I can touch within my home directory, desktop. And now if I run this ls-l again, take a look at the last time that desktop was touched. But touch, we said, will create an empty file. So again, there's nothing in this movies directory right now. I'm going to touch a file, and we'll call that file Gladiator. We're in movies. We created a file called Gladiator. By ls, I can see that there's now a file called Gladiator, and that file is black. It's not blue like those directories, which is my first sign, right? Let's go ahead and touch another file, and we'll call this one Inception. Spelling, touch, Inception. Clean my room, list the contents. We have two files within this movie directory now. We're using touch to create those empty files. And I can make a directory within this, and we'll call it Sharks. And then I can touch within the Sharks directory a file called Jaws. And notice how I did this with a relative path. When I say relative path, I mean a path from where we currently are, right? Relative to my current location, this Jaws file is inside of a directory called Sharks that I just made. An absolute path to this file would look something like touch/home/fstack/creations/movies/sharks/Jaws. This is a relative path to Jaws from this location. This is an absolute path to Jaws from root. Any questions about the difference between this absolute path or this relative path? And bonus question, I created this Jaws directory within Sharks, my last command. What's going to happen if I try to touch or create this Jaws file here with this absolute path? Joe says can't. Samantha says nothing. Mitchell says nothing. There's only one Jaws there. I'm going to run ls-l within this directory because the one thing I will point out is the differences in these colors here give us an idea that these files are formatted differently. They're of different types somehow. The very first bit within this permissions thing has a dash for the top two and a D for sharks. This D represents that sharks is a directory. These dashes represent that Gladiator and Inception are files. There's also a command called file. And this file command is going to tell me some information about the file that I feed it. So if I run file on something like Inception, and I can spell file Inception autocomplete, it tells me that it is an empty file. If I run file on something like sharks, it tells me that sharks is a directory. And as we get into some more advanced file types, this can be useful to sort of determine what a file actually is without assuming what a file actually is. So we created some movies. Let's go ahead and go to books here. And there's nothing in this books directory yet. So I want to create a new file within this books directory, and I want that file to be called Frankenstein. How am I going to do that? Touch Frankenstein. If I want to create more than one file, I can space separate. I don't have to do these one at a time. Remember, I said space separation is key. So if I want to touch Frankenstein, I can touch Frankenstein. I can also touch 1984. If I want to add another book. And touching both of those files created those two files, right? So I can touch Frankenstein, and then I can touch 1984, or I can touch Frankenstein in 1984. Both of these are perfectly acceptable ways of creating files. So I'm going to cd ... to go back to creations. And again, I can use print working directory to see exactly where I am. I can clear, can ls within here. And I still have my 3 child directories, books, movies, and shows that are within creations. Let's go ahead and let's cd to shows. And let's make some stuff here. I'm going to touch Friends and Seinfeld. And I'm going to make a new directory called game shows. And I'm going to cd to game shows. And within game shows, I can make some more files. Right? Let's touch Jeopardy. We have Jeopardy within game shows. And this is all fine and dandy. I'm creating all of these directories and I'm creating all of these files. And I'm moving around. There is a command that we can use. I'm going to cd back to my home directory. So I'm back in my home directory. There's a command that we can use to kind of visualize this file system. It's pre-installed within your Vocarium machine. It doesn't necessarily come by default in every flavor of Linux. It's easily downloadable. And within the next couple of days, we'll talk about installing packages and how we can install something that's not necessarily on our system. But I'm going to go ahead and ls here. And I can see that I'm in my home directories. And here's that creations directory that creates all of that has all of those directories and files that we just created regarding movies and books and TV shows. Command that I'm going to call is tree. And if I just run tree, it'll branch from my current directory, but I can also tell it where I want the tree to start. So I'm going to say, show me a tree that starts at creations. Now Linux is giving me a really sort of nice graphical output of what the file tree looks like starting at creations. It's telling me that there's 5 directories and 8 files within this file tree. And within creations, I have books and I have movies and I have shows. Within books, I have 2 books, 1984 and Frankenstein. Within movies, I have Gladiator, I have Inception. I also have a child directory called Sharks that has a movie called Jaws in it. And within shows, I have Friends and Seinfeld, and also a directory called Game Shows that has Jeopardy within it. Is there any confusion about how this file system is set up, how we're navigating around this file system? We're about to get into that, Sebastian. Something to note about this tree command is by default, it's going to show every single child directory and every single file and directory that's within those child directories all the way down the line until we get to the end of every branch, which is generally a file, but not always. It could be an empty directory, which means that we kind of have to be a little careful with how this looks. Because what if I do something like cd to the root directory, clear this out? Now I'm in my root directory. What's going to happen when I run tree right now? It's going to show me every single directory that's in the root directory and every single file and directory that's in those directories and every single file and directory that's in those directories, or in other words, every single file and directory within the file tree and how they all relate to each other. Remember, we said everything in Linux is a file. That means every piece of hardware I have installed, every driver, everything is some type of file. I'm gonna let this go for a little bit longer. And we hit the end of the road. There's only 404, almost 405,000 files within this file system. And only about 44,000 directories. No big deal, right? I could zoom through, I could just keep scrolling through this for days and days and days and days and days and days and days. But at the end of the day, if I go all the way up to the top of this tree, it doesn't even have enough memory to show me that. Let's go ahead and just clear the room. The idea is that depending on where you run this tree from, you may get some really messy output. Before we start talking about removing files, the last thing that I kind of want to introduce to you is the idea of getting help from the system. And we generally do that with manual pages or man pages. So we know that ls lists the contents of a directory. I can use the command man to check to see if there's a manual for a particular tool or command. And this will open the manual page for ls for me. And it tells me that ls lists directory contents. I can come through and sort of read through what each of these options do. We can list entries by columns. We can list directories. We can list by classification. We can show groups, or we can not show groups, not print group names. There's all sorts of options here. I can use my / to search. If I want to look for something like long, it's going to show me here's the first instance of long in a long listing. Don't print name groups. N will show me the next occurrence of long. This is not the easiest interface to work through, but it's available to you via the command line. A lot of times what I like to do is look up these man pages in a web browser. Since I have that resource available to me, they're a little bit easier to read in that location. But sometimes we might be on a system that doesn't have a web browser. We could just have command line interface to some headless server, and the only way that I can interact with it is the command line. There is no web browser for me to open. So understanding that I can identify things like a man page is helpful in that way. We look at something like touch. We talked about touch and how that will create an empty file, but I was careful to say that's not all that it does. Right? Here it says that touch is actually used to change file timestamps. Q will quit out of these man pages at any time too. But understanding that these are here, here's man tree, and it'll tell me all about this tree command and options that exist. I can list directories only. I can print the full path prefix. So there's all sorts of options for all of these commands that we're learning. And Mikey and I are not going to walk you through every single option. We'll walk you through some of the main ones that you need to know. But part of learning these commands in a professional way is learning all the things that you can potentially do with them. We're going to start slow. Before we get into removing stuff, we created stuff. Before we get into removing stuff, let's review some of the commands that we've learned. We talked about who am I? And who am I tells us what? Username, current user, yep. And host name tells us what? Host, machine name, current machine. I'll take it. I love it. PWD tells me what? My current directory. LS tells me what? List my directory contents. And CD does what? Change directories. So I can change directories to templates here. And if I want to get out of templates, what's one of the ways that I can get out of templates and go back to my home directory? Yep. CD ... will take me one step back, which would take me to home. I could also CD directly to my home directory with a tilde. I also have the option to just hit CD with no option, which will also by default always take me home. I'm going to, before we delete stuff, I'm going to show you how we can copy or move some things. I'm going to touch a file here, and I'm going to call this file move me. And if I ls, I have a move me file that is within my home directory. I'm gonna, let's copy it first. Let's move it. It says move. So I'm gonna move. MV is my command to move a file. And if I'm gonna move a file, I need to provide two options. First, the object that I want to move. In this case, it's a file called move me, and then where I want to move it to. And I can do this via a absolute path or a relative path. So I'm going to move me to demo2 / moved. There's no slash at the end of this command, which means I want to name this file moved once it's moved. It's called move me. I want to move it to demo2 and we'll call it moved. Again, if Linux doesn't do anything, I'm going to assume that things went right. And move me is no longer in my current directory. Guess where it is? It's in demo2. And I'm just going to use ls to point to demo2 from here. Again, we'll demonstrate the idea that we don't have to just list our current directory. I could say, show me what's in demo2. And it tells me that there's an ssh.log file and my moved file again. Okay, well, what if I want to move it back? I can move it from here. I just need to change where that path is, because I'm not pointing to where the path to where I want to move the file to. I'm going to point to where the file is and bring it to myself. So I can move within demo2 the file called moved to my current directory. This is going to move moved to my current directory. And since I didn't provide another file name, guess what it's going to be called? It's back, and it's called moved. If I ls what's in that demo2 directory again, just our ssh.log is there. We've move back. The other thing I can do is move a file like moved to my current directory and call it renamed. This is, I know I will always want to hesitate to say the only, but this is the rename option within the Linux command line. There is no rename command, but what we can do is move a file to a new name in the same location. The other thing I can do is copy a file, and the syntax looks very similar to move. The difference is we'll keep our original, right? So I can copy renamed to second named. And if I ls, I have both of those files here, and they're copies of each other. I could also copy second name, and I can put it somewhere else, right? I can say, well, let's put second name inside of demo1, and we'll call it third name. Now, if I ls within demo1, there's a copy of that file called third name. The more you get used to this type of stuff, the more straightforward it will be. So we can copy files. What if I want to copy an entire directory? Let's try it first. I want to get used to using what things look like when they work and what things look like when they don't work. What if I want to move the creations directory or copy the creations directory to creations backup? I got some output, which means I should pay attention to it. remember that when things go right, it's generally quiet. So it says, with regards to your copy command, -R is not specified, omitting the directory creations. So if I ls, there is no copy of creations made, and it's pointing me towards this -R option, which is a shortcut you'll see for a lot of, or an option or an argument you'll see for a lot of commands. And it refers to recursive, the idea of this command being recursive. So instead of copying the creations directory and getting that issue, copy -R is going to recursively copy that creations directory, which means a lot like that tree command. It's going to copy the creations directory, and it's also going to copy all of the directories that are within that directory, and all of the files that are within that directory, and all of the directories and files that are within those child directories, and all the directories and files that are within there, and all the directories and files that are in there as well. So if I run this command and say copy recursively creations and put it in creations backup, I see that I don't get an error. And I do have a new directory called creations backup. And if I run tree on this creations backup, it recursively copied all of those directories and files that we had created before. If I want to remove items, that was the other question. Command to remove is RM. So if I want to remove that second named, I can use RM and call that file name. And it tells me that it's been removed. I can remove renamed, and it tells me that I was removed. I think I have a file in demo1. Let's ls demo1. I have this third name. Let's remove that. Let's remove it from here. I'm in my home directory, so I need to remove it and give a relative path to where it is. Within demo1, I want you to remove the file called third name. And now if I ls demo1 again, I've removed it sort of remotely. I just had to give directions to where it is. Again, there can only be one file name by one location. By giving it this file name, this file path, I'm specifying exactly which third name I want to be removed. What if I want to remove this creations directory? Do we think that this is going to work? Garrett gave me a hard, fast no. Why not, Garrett? Sebastian, if it says no file exists, it may be a syntax error within your path, or a misspelling in the file name. But it's not a file, it's a directory. Well, let's just, for fun, let's make a directory called test directory. And I see that it does exist. I'm going to remove test directory. It says it is a directory. So we weren't able to copy that creations backup unless we used an option. How do we think I might be able to remove a directory? Adasol is on it. RM-R will use that remove recursively to remove the creations directory and any directories that are within it. By ls, there is no more creations directory here. And if I rm-r, I'll always get rid of those recursive directories. There is an option that calls for rmdir. This is only going to work assuming that that directory is empty. If I try to rmdir this creations backup, it tells me, sorry, I cannot rmdir that directory. It's not empty. If I rmdir this test directory that I created that has nothing in it, I'm perfectly fine. And we can see that that test directory is gone. This is not even really a need to know relevant information, right? For all intents and purposes, you could recursively remove an empty directory as well and get to the same effect. But I do want to point out that there is an option to make dir and rmdir. rm-r means recursively remove. So again, when we say that we have this backup creations backup, if I run tree on this creations backup, it's going to recursively map out this directory, which means it's going to tell me what's in the side of this directory. It's these 3 directories. It's also going to tell me what's inside of each of those directories, which is all of these files. And if there's a directory inside of that directory, it's going to show me what's inside that. And this will never end until the file path ends. I could have a directory inside game shows that says old game shows, and I could have a directory inside old game shows that says black and white game shows, and I could have a directory inside black and white game shows that has a list of old black and white game shows, and all of those would be listed within this tree because the tree is listing recursively. So when I say rm-r a directory, or copy-r a directory, like creations backup, let's go back to creations. I've copied recursively that entire directory, which means the directory and every single thing that's in it. There is some danger here. If rm-r recursively removes everything, we could imagine there's a little bit more that comes to play because of permissions and some other things. But functionally, we can imagine how doing something like this could be troublesome, right? Again, there's permissions and some other options that would have to be taken into account. But theoretically, what would this do? Delete everything. And by everything, I mean everything. I mean the entire operating system, every configuration file, everything. It's not quite that simple, but it's not much more complex than that to completely crash it. Again, don't be scared. All we'd have to do is hit reset. This is a virtual machine. And in 3 to 5 minutes, we're back in action and we're going at it. So just to recap, we've talked about who am I? We've talked about host name. We've talked about present working directory. We've talked about ls, and we've talked about ls-l for that long listing, sort of adding that argument. We've talked about changing directories, either to a name or changing directories to a parent directory to move backwards. Relative and absolute paths. We talked about touching files. We talked about making directories. We talked about removing files or recursively removing files to delete an entire directory. We talked about moving a file. Talked about copying a file. We talked about manual pages. It's a lot, right? But if we take it one step at a time, we're getting there. These are fundamental things that we need to know to be able to operate within this command line. There's one other topic that I want to make sure that we touch on that can make our lives a little bit easier sometimes. And it's the idea of using wildcards. There are a few options that we can use. I'm going to introduce you to one major wildcard command for today. We'll revisit the idea of these wildcards a little bit later in the curriculum. But for demonstration purposes, I'm going to make a directory here and I'm going to call it wildcards. And if I ls, I can see that this wildcards directory was created. I can go ahead and cd into that wildcards directory here. And I'm in here. I'm going to touch a few files. I'm going to touch file 1. I'm going to touch file 2. I'm going to touch file 3. I'm going to touch 1.txt, 2.txt, 3.txt, and we'll call it there. So again, space separating that touch command allows me to touch all of these files at once. Wildcards are a good way for us to sort of encompass multiple files that may share common name attributes. And the one wildcard symbol that I want to introduce you to today is this asterisk or this star. And what this represents is any potential character or character set or no character at all. So what does that mean and how can I use it? Well, I can use it a few different ways. I can do something like ls-l file 1, right? And if I just run ls-l, let's back up. If I just run ls-l, it shows me the long listing for every single file in this directory. I have 6 files, no big deal. I may have 600. So I'm going to clear this out. And I can also ls-l one particular file, like file 1. And it will show me the long listing just for the file that I've called. I can use a wildcard to isolate some of these files that may have something in common. So I can say something like ls-l file wildcard. And that's going to tell me any file that begins with file and has anything or nothing after that. That's going to include file 1. That's going to include file 2. That's going to include file 3. If there was a file just called file, it would also include that file. It can mean nothing at all. However, if I have a file called e-file, it's not included. It needs to begin with this pattern and can end with anything after it or nothing after it at all. So this is going to list for me the long listing for any file that begins with file, which is those 3 files. I could use the opposite approach, and I could say ls-l for me, the long listing for any file that ends with .txt. And this will include for me 1.txt, 3.txt, 2.txt. They're in alphabetical order, not numerical order. But I've isolated every file that ends in txt. There's times that this can be useful, right? The third sort of general way that we can use this wildcard is I could say ls-l and use a wildcard at the beginning and the after, and that's going to show anything that includes a particular pattern. So any file that includes a lowercase o anywhere in the file is going to be listed. I could ls-l anything that includes 2 consecutive e's. There's only one, 3.txt. This is a topic that we'll revisit, and we'll talk about some other potential wildcard options. But for now, for the sake of today's cohort connection, I want to introduce you to this asterisk, which can be any character or any set of characters or no character at all. For the sake of demonstration, let's do that. Let's touch file and let's touch some file. Oh, touch some file. Clear list. Now I have multiple files that include file. I have some file, I have file 1, file 2, and file 3. If I ls-l, file asterisk, this is going to show me everything that begins with F-I-L-E. How many of these files will this list? Saw 1 5. I saw some 4s. I see another 5. I see 4s. There are 5 files that include file, right? Only 4 of those files begin with F-I-L-E. Some file includes these characters before the F that I haven't accounted for in the wildcard. The wildcard saying the first character in the file name is F, the second I, the third L, and the fourth E. It doesn't matter if there's anything or nothing after that. It needs to have that beginning. If I want to include all 5, I could generate this wildcard output, which says any file that includes file anywhere. It could be at the beginning, it could be in the middle, it could be at the end, or it could just be the word file. And now I'm getting all 5. The location of where this asterisk is located is key. If it's at the end of the file name, we're calling any file that begins with this pattern. If it's at the beginning of the file name, we're talking about any file that ends with a particular pattern. We use the example of anything.txt. And that doesn't matter what the beginning of the file is. It could be called 1.txt, 2.txt, or declaration of independence.txt. Either way, it's calling that ending pattern. Yes, Mikey's absolutely right. I could create a file called fire1. Touche. I
gotta install the fencing package.
So now I have files. I also have fires. So if I want to sort of refer to what Mikey was saying, I could ls-l. And again, I could use any command. I'm using ls-l so we can get some output. These are all empty files, which makes output a little tricky. But I can ls-l fi wildcard e wildcard, and this is going to include all of those files that begin with file, but this third space is a wildcard, which means that it would include the fire file as well. And remember that this can be any character or no character or any character set. Let's touch a couple more files, and let's touch fi1 or just fi, and let's touch fi play. If I run that same listing again, this is going to include all the files that begin with file. This is going to include fire, because that can also be any character like an R. It's also going to include fi, because that could be no character, and can also include fillet, because this doesn't have to be a single character. It can be a character set. And I have an fi, some character set, an e, and then something else as well. So all of these are now included. We can get granular. And there's also, like I said, the star is not our only option. There's a set of wildcard symbols that we can use. We're going to keep it general for today, but that is a great point. It can be placed anywhere within this pattern set. Let's take a look at the cohort connection so that we can kind of get an idea of what you're going to be working through in your breakout rooms. There's always sort of an introduction here that I recommend reading. It's going to give you sort of a backup idea of what we're talking about, where we are. A lot of times it'll give you a hypothetical situation to consider as you're going through these exercises. But as your team, please don't just start jumping down to where exercises are. Really, really read through this, figure out what's going on, set yourself up for success. There's a few parts here. The first is on virtual machines. We sort of covered this morning, but this is the idea of just starting up the virtual machine, operating within that Vocarium environment. Remember that we can always extend this lab. And it says my lab has been extended. Recommendo. Otherwise, in about an hour and a half, this is just going to shut down on me. And I'll have to re-click the link from Canvas and reboot that spinning V in order to continue working. The second part is with regards to navigating the terminal. It says here, we talk about setting up files and directories, digging through files to find data that might be of interest, finding files that warrant further inspection. And this is the general setup that these cohort connections will look like. There'll be some type of demonstration that's done during the demo, during the lecture. There's an exercise that's for you and your group to work through, and a lot of times some supplemental information, commands, reference material for you to use. So it says here, observe reading a prompt. We talked about that prompt, right? The username at the host name. Then it has a relative path from our home directory to where we are. And that $sign that represents our regular user. Again, this is what we're talking about when we're referring to a prompt. We're referring to everything from the beginning of that username to the symbol after the file path. We talked about changing directories from one to another using that CD command. We talked about reviewing the contents of a directory by listing its contents with ls. And we talked about creating directories and files with mkdir and touch to create those empty files. There's exercises for you to work through here. And these exercises, like I said, are all independently built into the operating system for you to set up at any time so that no lesson relies on the lesson before it. You can always just boot up the current lesson. And the way that we do that is by running these setup commands. We'll talk about what sudo is, but long story short, sudo allows you to run a single command as an administrative user, rather than switching to that root user, that where we saw that pound octothorpe hashtag instead of our $sign. The more secure way to do this is to have a user that has sudo privileges that can run particular commands as that administrator rather than every command as that administrator. Your user fstack has sudo privileges. So we're going to run basically this command as sudo. And what this is going to do is in the background, run a script that sets up your entire lab for you. And the password for that user is Academy. That's going to be a common thing when it comes to these Vocarium attributes. So I'm going to clear this out. I'm going to CD to go home, even though I could run it from anywhere. And let's do this one together since it's our first one ever. I'm not going to do the entire exercise, but the setup. It says to run, and anytime you see this, it means type exactly this. Run sudo practice activity 1A setup, and it prompts me that the password is Academy. Sudo practice activity 1A setup. Again, it asked me for the password for my FStack user, and that password is Academy. For security purposes, this is masked, and you will not see the keys that you're typing. They are there. So I just typed Academy. It looks like I didn't, but I did. I'm gonna hit enter, and it tells me that it's cleaning up whatever leftovers that may have been on the system, and it's creating home FStack practice activity 1A directory, and it's done. So the lab has been set up, and I can CD to that directory. I'm in home, so practice activity 1A, and here is the directory at hand. There's nothing in here, but it created this directory for us. At other times, it will do a whole bunch of additional setup stuff. The goal here that isn't really explicitly listed, it's one of the, I'm not extremely happy that it's the first exercise and it's not as explicit as it could be, but it says change to activity 1A directory and create the following. This is a series of directories. It wants you to recreate this directory tree within the activity 1A directory. So if I'm in activity 1A and I run tree, there's currently no files or no directories within that tree. I want to recreate this tree, meaning I need a directory called ops, and inside of a directory called ops, I need directories called hosts, keys, log, packages, and users. And inside of that directory called hosts, I want two directories called local and remote. It's going to ask you, once you do that, to create some more files within those directories. But this is the task at hand with this first exercise. Sort of just walk through these procedures step by step. We'll recreate this directory tree, and then we'll add some files, insert some files into that tree as well. We talked about creating and removing directories. Again, there's some more information that you can read through here. But for the demonstration purposes, we talked about copying files and directories by using relative and absolute file paths. We copied files right into the directory that we were in using that single dot. We copied files into other directories by using relative paths. And we talked about how we could use that absolute path too. Sometimes it can be a little long, but it's very explicit. And when we copied the, it wasn't a copy, it was a creation, but we had that path that went all the way from root to shark, right? Slash home slash fstack slash creations slash movies slash sharks. That's an absolute path. It starts at root. We talked about moving files and directories with that MV command. And we talked about removing files and directories with RM and RM-R to recursively remove those directories. Again, there's always supplemental information. If you look here, it kind of gives syntax for all the commands that we walked through. And there's an exercise here. Again, you'll have to run another practice setup command, and it'll set up a whole new lab environment for you to work through this second exercise. If you ever want to rework these exercises, you can run sudo practice activity name cleanup, and it will undo everything that you did, and you can reset the activity and work through it again. So we can always go back and work through these as well. So we'll break out, and I want you to, in your teams, work through these two exercises, the part 2 and the part 3 exercise, and see how far you can get through there until lunch. After lunch, I do want to talk a little bit about the other virtual machine and what your workshop will look like, since it is sort of our first real hands-on workshop as well. So focus on the cohort connection for now. After lunch, we will review a little bit of material that relates to that workshop. We'll break back out, and you can wrap up the cohort connection and move on to that workshop as well. Any questions before we pop into those breakout rooms? And don't forget, if you do run into questions while you're working, that help ticket channel is available to you just write a thoughtful ticket and a member of the instructional team will zoom right in to give you some assistance.
And please remember to include error messages if you're getting errors. That will solve our first two questions that we inevitably have to come and ask.
And to be honest, it can feel a little bit like a pain in the butt to thoughtfully write those help messages, but you'd be surprised how thinking and writing your process out in that way can a lot of times even get you to catch what you were missing before you hit that enter button. You can say, you know what, now that I had to think about it, I think I know what the issue is. It's surprising how often that can happen. Awesome. You know where to find us if you need us. Otherwise, Rahul, Loki, whenever you're ready, we can bust out. The workshops are self-guided. So like we stated yesterday, not everything that's in the workshops will always be explicitly walked through by Mikey or myself. We'll try to hand to you the stuff that you really need to know, but there are resources there, videos to watch, things to read. The idea is we are also learning to be self-learners, and that lifelong learning process has to continue after this boot camp without the guidance of the instructional team by your side. So these workshops sort of work you into digesting material other ways rather than through these lectures. But since this is the first day that we're working on these virtual machines, I wanted to kind of introduce you to the differences between these two initial machines and sort of what they're each used for. I'm going to share my screen out. My resolution's funky with this first one, but it's all fine. This is the Ubuntu machine, your Linux VM that we were working on for the demo today. The second virtual machine is the CyberLab machine, which is this Mint machine. So immediately identifying each one by its initial startup will help you determine whether or not you're in the right place. This Black Mint machine is going to be used explicitly for CyberLab exercises. So if we look at today's workshop and we start at the top, there is a workshop guide here that you can sort of take to organize your thoughts as you're working through this workshop. These are not documents that will have you turn in. It's not absolutely mandatory that you do the work, that you document the work within that document, but it's provided to you if you want to organize yourself that way. Here's the moments that we really need to pay attention to detail so that we don't end up working in the wrong environment. There's a list here that tells you exactly what virtual machines you'll need prior to beginning each part of the workshop, and it's separated by sections. So part 1 explicitly states that you'll need the CyberLab VM, which is that Black Mint machine. Blocks 2 and 3, or part 2 and 3, say that you can use either machine. The Linux machine is fine. The CyberLab machine is also optionally perfectly fine. And for the 4th section of today's workshop, you won't need either one of the machines. So as we're scrolling through and we're sort of thoughtfully reading all of this stuff, we get to the idea of these capture the flag exercises. And capture the flag, or CTF, is a term that you'll hear a lot, not only within cybersecurity, but especially within cybersecurity. And it's sort of the idea of gamifying, with regards to CyberLab, it's an idea of sort of gamifying our learning experience a little bit and using the tools that we're learning to sort of search for these hidden flags that are buried within this machine. There are capture the flag exercises that are done live in real time, where there's a red team trying to capture some type of flag while the blue team is defending this data or this flag. With our case here, these are hidden flags, and we're sort of going to solve questions or riddles to find these flags using the tools that we're learning throughout the cohort. The flag formats look as follows: capital S, or capital F, capital S, and then within curly brackets, some string or some collection of characters that stand as the flag. So it says here, as a reward for making it this far, here's your first flag. And we see that it has that format, FS curly brackets. And within these curly brackets, there's some thread of text. Here it sort of says in leet speak, you've passed the very first test, and it has a encoded tag here at the end. This is just a reference to hints. A lot of times when you're going through these questions, there'll be hints provided. We can unlock these hints just this way. These are just general hints. And there's another flag here that we found. I would say that checking these hints can be not only helpful, but sometimes necessary. They're labeled as hints, but they're really extra information. Sometimes it can be very difficult to solve these problems without checking the hints. So don't feel like if you're checking the hints that it's because you're not able to figure it out. Sometimes there's information embedded within those hints that we need to know. So here's sort of the first flag that we can actually find within the VM, and it says start your VM. To solve this first challenge, find the first flag, simply run your VM and open the openme.txt document located on the desktop. There are references in here to Kali. We will be using Kali Linux later in the program. These flags were originally embedded in a Kali version of Linux before they were transferred over to this Mint machine. But we can see there is the openme.txt file, and that text file, if we open it, I'm going to open it through the GUI for now. And we can see that there's some information here, and specifically the next flag is buried in here. So I'm not going to go through each of these flags, but I just want to introduce to you the idea of searching for those flags, what those flags look like, and make sure we confirm the fact that the only place to find those flags is within this Linux Mint environment. Again, this is very much like our Ubuntu environment. If I open this terminal, it gives me a prompt that's very similar to the Ubuntu, but rather than saying fstack at Ubuntu, here we have fullstack at fullstack. All of my commands still work, right? Who am I? Print my working directory, ls. This is just another Linux machine. It's colored a little bit differently, but as far as functional wise within that terminal, it's exactly the same. Any questions about those two machines and what the difference is between the two of them? You may notice here that it says you need to enter this code into cyberlab.fullstackacademy.com. This was an old resource that we used to have to submit and check these keys. Fullstack at this point has discontinued. That resource is no longer available. If and when an alternative becomes available, Mikey and I will point you towards that. For now, organize and keep these keys wherever you can find them on your host system. We don't want to save them on the VM because we need to reset those VMs, you'll lose them. But just open a text document or use those resources available within the workshop, the answer sheets here, to document where those flags are, but you won't be actually submitting them. Alexa, your question with regards to persistent, do you mean the VMs?
Yeah, so basically anything that we do inside of the VM basically gets saved.
Within the Vocarium system, these VMs are pretty volatile and we're not really able to create snapshots or anything like that. There is a workshop available that we'll be posting, and the instructional team can help students if they're interested in setting up a local hypervisor to host VMs locally. We don't have all of these instances available to host locally, but we can get a Linux machine running locally on your computer. In that case, you'll be able to save snapshots and get a little bit more persistent. But unfortunately, with the way that Vocarium operates, it is volatile in the sense that if something goes wrong, and something probably will at some point, and we reset that machine, you'll lose your saved data. So anything that you really want to keep, I would store on your host machine. So we'll work through this capture the flag. I wanted to make sure that we sort of discuss this capture the flag, what those flags look like. And then we'll do a little bit of experimentation with what you'll be seeing within the rest of the workshop. I'm not going to walk you through the workshop, but I will sort of give you a peek into what the workshop is going to cover. And really, the big takeaway for the workshop is that it's going to talk about previewing files and different ways that we can sort of peek into files. We created and deleted files and created and deleted directories today, but all of the files that we created were empty. So if I open my terminal here and I ls in my home directory, we can touch a file, right? I can touch, I'll just call it empty file. And if I run file on this empty file, it tells me immediately that this file is empty. And I can run ls-l on this empty file for a long listing. Remember that this gives me some information about the file. And the size of the file is also 0. There's nothing in here. So there's no way for me to view this file. But if there is something in a file, for instance, we go to demo2, there is a file in here called ssh.log. And if I run file on this file to find some more information about what it is, it tells me that it's ASCII text. This is basically a text file that uses Western American English characters. Sometimes you'll see things embedded in Unicode. That's also human readable text, but it includes Cyrillic characters and all sorts of universal characters. But this is a text document. And if I run ls-l on this file, we can see that it does have some content. There's something in here. So how can we view the contents of this file? There's a few ways we can do it. The first most general one is with a command called cat. And I'm going to keep referring to these band pages so we can get sort of used to checking them out. Command cat. And it says that cat concatenates files and prints on the standard output. So it can output more than one file. We can feed it more than one file. But the big takeaway here is that we get a name and sort of a very, very brief description. And then there's always this synopsis that gives us the syntax by which we're going to use this command. So it says we'll call cat, provide options if necessary, and provide a file if necessary. It says it concatenates files to standard output. And if there's no file entered, or if the file is a dash, then it's going to read standard input, which just means it's going to allow us to sort of type and echo back. That's not too useful for us at this point. Remember, Q will get us out of these man pages, but let's take a look at that. It says if I enter nothing, it's going to read standard input, right? So if I just run cat, it's just waiting for me. Anything that I type is going to just get concatenated back to me. The real purpose of this cat command is we want to preview what's in this file or see what is in this file. So if I run cat on this ssh.log, I get the output of this log file. And it starts me all the way at the bottom. It just prints it, and I'm at the bottom, and I can sort of scroll up to the top, and I can try to read this file this way. Again, the resolution is funky, and notice how awkward it is. I have to go up and find the top of this file. There's a few other ways that we can read files that can be a little bit more helpful. And I'm going to back up out of here. You do not have this file on your systems. I created this file, but I think it's going to more easily demonstrate the different ways that we can read a file. I have this file called hat.txt that I created. And if I run the cat command on this hat.txt file, it bumps me out a bunch of output. This output is actually the Cat in the Hat. It's the text from the book, The Cat in the Hat, right? And reading this way, again, is not that easy. I have to find where the top of it is, and then I can sort of try to scroll through here, but the scroll is very sensitive. it's not the most beneficial way to read something from top to bottom, right? So there's a few other commands that we can introduce. I'm going to open a man page again. And the first one is a command called more. And it says here that this is a file perusal filter for CRT viewing. And in the description, it says more is a filter for paging through text one screen full at a time. This version is especially primitive. Users should realize that less provides more emulation plus extensive enhancements. And we'll take a look at less as well. But for now, let's see the difference between cat and more. We saw that when I catted the file, it just dumps it to standard output. If I run the more command on this hat.txt file, it starts at the top here, and it's going to give me one page of input. And it tells me that this is 5% of the total document. But I can go through this page, and with the space bar, I can start page by page working through this read, right? I have 18% displayed here. Now we're at 24. And it's just one chunk at a time, one page at a time, scrolling through this text document. I can't go the other way. I can kind of scroll up, but I can only chunk page by page on my way down with the space bar. And that's fine. I'm going to hit Q to get out of here, clear my screen. And we saw that on the man page for more, it specifically pointed us towards a command called less, which is sort of jokingly the inverse of more. It is more that does more, which is less. But it says here, less is the opposite of more. And in the description, we read that less is a program similar to more, but it has many more features. Less does not have to read the entire input file before starting. So with large input files, it starts up faster than text editors like Vi. Less uses term cap or term info on some systems, so it can run a variety of terminals. There is even limited support for hard copy terminals, in which case the lines printed at the top of the screen will be prefixed with an indent caret. It says commands are based on both more and Vi, and commands can be preceded by a decimal number called n. That's sort of beyond the scope of what we need to know. But we can read through and check these options here, or never forget that there's resources online available to you as well. Things like Geeks for Geeks or W3 Schools is a great way to also look at sort of some of the usages and examples, especially examples for these commands. But if I run less on this file, we'll see that it gives me a little bit more functionality than more does. Starts at the top, just like more did. And if I hit my space bar, it's scrolling page by page, just like more does. However, if I use my arrow keys up and down, I now have granular movement line by line this way, which is much more readable than chunking page by page, right? Now I can kind of scroll through here. On top of that, just like the man pages, less actually gives me functionality to search. So if I use a /, I can look for instances of cat within this document and have search functionality as well. Those are not every explicit difference, but those are some of the big differences between less and more. So you might be wondering, if I know less, why do I need to know more? You don't, but it's a legacy command and we're going to introduce it. So cat to just dump a file, more to chunk page by page, less will allow that granular arrow line by line scrolling, as well as chunking page by page like more with the space bar, and some search functionality. Those are the biggest takeaways. So we know how to output files. The last thing that your workshop is going to talk about is man pages, which we've covered, and also the idea of sorting data. And we'll learn some more commands that will help us to sort data in the command line when we get into a little bit a little bit further into bash techniques, there's multiple commands that we can use to sort of sort and parse output from the command line. But the big one that we're going to cover with the workshop is sort. And sort works a few different ways. Let's man this sort page. It says it sorts lines of a text file. Written sorted concatenation of all files to standard output with no file. It reads standard input, just like cat. It says mandatory arguments to long options are mandatory. Okay. So same thing, we have a synopsis here, and we are going to run sort our options and whatever the file is. And we'll cover a couple of these options. But first, let's just look at sort by default. I have a couple more files. Again, these are files that won't be on your system. I've created these files during lunch. But the first one is names. And if I cat this names file, I get a bunch of one word names, right? And there are repeats here as well. But this is all names. So if I cat this, if I cat this names file, it's going to dump in the order that the file is listed. So can I use sort to sort this output? I absolutely can. If I run sort on names, all of a sudden I get the names in alphabetical order, right? And notice that there are repeats here. So what else can I do with sort? Can I reverse it? Let's see. I'm going to go to the man page and let's search for reverse. And it says that -r or -- reverse will reverse the result of comparison. So rather than sorting in alphabetical order, sort -r, and notice that these options, these switches, these tags are not universal for every command. What was -r when we used it with copy or remove? Right. Recursive removal, recursive copying. The same -r tag for the sort command serves a totally different purpose. It's a reversal. So if I run reverse sort on names, all of a sudden my A's are at the bottom, my Z's are at the top. Let's man sort again. And let's see if we can find anything about uniqueness. And this is another popular option. There is a tool called unique. We're not going to worry about it today. I'm going to show you the way to implement that same unique functionality with this -u option within sort. So it says that this is going to check for strict ordering without -c output, only the first of an equal will run. What does that mean? I'm going to run sort. Let's just run sort on names first. And I see that I get that output. These outputs are consecutive. These repeats are consecutive. So that -u option is going to allow for those consecutive repeats to be omitted. And we'll get only individual unique outputs sorted from that output. Can these tags be combined? I don't know. Let's try. What if I run sort and -r and -u on names? I'm in reverse order, and I'm having unique outputs with no repeats. So we covered sort, we covered sorting in reverse order, we covered sorting and outputting only unique outputs, or in other words, avoiding repeats. So what else can we do? We can, depending on what our data looks like, we can do some other search or some other sort options. I have one final file here, and it's called states. I'm going to cat this states. Actually, let's run states through less. I'm going to run less on states. And I see that I have output here that's equal to state names and a number. Anyone guess what this number is? Just curious. Yeah, they're electoral college votes, but these states are in random order. These votes are in random order, right? Can we agree on that? Oregon, Maryland, Vermont, Rhode Island, Louisiana, Montana, North Carolina, Kansas. This is in no type of alphabetical order. 7, 10, 3, 4, 8, 3, 15, 6, 11, 3, 3, 55. These are in no numerical order. If I run sort on this states file, what do we think that this output is going to look like? What did it do to our list of names? Alphabetized it, right? And it did. When I run sort this way, I'm starting with my states that start with A's. I'm moving alphabetically through. And the numbers still correlate to whatever states are in alphabetical order. What if I want to sort by this number? There actually is a way that we can sort by column. And by default, we're going to assume that a space is our delimiter. So if I cat this states again, we can see that there's no spaces within the name of these states, but there is a space between the name and the number that comes after. So by default, that space is going to be a delimiter, and we can use a -K option to choose which column we want to sort. So if I sort -K2 on this states file, these states are not in alphabetical order anymore, right? However, look at how these numbers are sorted. 10, 11, 12, 13, 15, 16, 20, 29, then 3. Why does 29 come before 3 if we're sorting numbers? It's still sorting alphanumerically, right? It's not sorting by counting numbers. It's sorting by characters. So 1 and then 1 comes before 1 and then 2, just like a name Aaron with 2 A's would come alphabetically before a name Abraham that goes AB. So how can we account for that? Let's check the man page. And let's search for something like numeric. And we see that G gives us a general numeric sort. H gives us a human numeric sort, so we can read things like 2 kilograms or 1 gram. N gives us a strict numerical sort. So if I want to incorporate all of that, I'm going to need to sort. We said that I can use -K to determine which column I want to sort by. And then I can use -N, right? And that should give me a numerical sort. And if I run this on states, this output has changed. I'm now sorting numerically. So 3 comes before 4, and 3 and 4 both come before 10. 10 comes after 9, and this is now a logical numerically sorted output. Could I do this now? What is this going to do? going to do all of that in reverse, right? It's going to sort by the numbers. It's going to consider those numbers to be sorted numerically, and it's going to reverse that output. So we should get California with 55 votes at the top and Alaska with 3 at the bottom. Does it matter where we put the R? That is a great question. And the answer is depends on the command. Some commands are very specific about which order these options go in. Others are not. So here I'm going to run a -R -K2-N, and I have no problem at all. There are some Linux commands. These are like I said, this -R for sort is not an equivalent to the -R for another command. And these are all programs that were developed and included into the Linux environment, right? They're not all created by the same individual or the same entities, and they don't all work exactly the same. And Mikey has a good point there. I can reverse any of those options. I could say sort -N -R -K2, or I could sort -N -K2-R, or I could search -K2 -R and -N. But what I can't do is run -R -K-N 2. This 2 is directly related to my -K option. So as soon as I run that -K, it's expecting some output for which column I want to search, whether that's 1, 2, 3, 4. I might have an input that has 6 different columns. And later on, we'll get into how we can differentiate how we're determining those columns, right? By default, it's a space. It doesn't have to be a space. For now, we're not going to overwhelm ourselves. Let's take a look because I mentioned it. Geeks for Geeks is a great resource for things like this, but I'm just going to look for sort Linux. And it says, here's the sort command, Linux and Unix with examples. And these are resources that I really like because it gives you everything you need to know that comes from the man page, plus examples and things like that. So it says, here's the syntax, here's options that are available, here's how to sort things. And as you scroll through, it'll walk you through each of these introductions. So here's all of our options. Here's our -R for reverse that we looked at. Here's our -K to sort a table based on a column number. And there's syntax on how to use it. So it says, let's start with a simple example. We can cat this file, then we can sort this file. Here's what the catted output looks like. Here's what the sorted output looks like. Then it'll show you a few options, how to do numeric sorting in lines of text using the sort command. How to sort lines in reverse order. These are all things that we've essentially covered. Stack Overflow is also a great one. So is W3 Schools. These are all free resources that by all means, I recommend checking out. We don't have to do things the hard way, right? Do know that those man pages exist because like I said earlier, you don't always have the luxury of having a web browser to pop open and search for anything that you want. I think that is about all that you really need to know, and everything that I just covered with regards to cat, sort, tail, or actually that's the one thing that we didn't cover, which is very simple. Let me just do that while we're here. We said that we can cat a file, right? Like we catted hat.txt, and it gives us all of that output. Sometimes, especially with things like log files, we might not want to check the whole file. We may be interested in just the beginning or just the end of a file. And the two commands that we can use there are head and tail. And just like they sound, head is going to show us the beginning of any particular document. If I run head on this hat.txt, it's going to, by default, give me the first 10 lines of this file and the first 10 lines only. I said by default because we can change it. There's a -n for number of line options. I can say, just show me the first 3. And I need to give it a file name. Head-3 on hat.txt. And this will give me just the first 3 lines. And I could say head-n25, and this would give me, again, I need the file name. And this would give me the first 25 lines. The other command is exactly the inverse. If I run tail on this command, then it gives me the last 10 lines. And the same options are available. I could say tail -n2, and this would give me the last 2 lines of the file. For the sake of considering it, let's go back to this demo2 directory. And there's this SSH log that we have in here. I'm going to run less on this, so we can go through and I know that this is small. My resolution's all funky, and I want to be able to visualize this one line at a time. But as we're coming through, there's a timestamp here, right? February 1st, 7:45, then 8, then 9. What do we notice about this log? It's in chronological order, right? The oldest entries are at the top, which means that the newest entries are at the bottom of that file. So if I want to look at the most recent entries of this log file, let's do this. There's other ways that we'll learn to do this, but for now, I'm going to say, I think it's cat-n will give me line numbers on this ssh.log. There's almost 500 lines in this log file. If I'm only interested with what happened very recently, I might not need to look at all 500 lines. I might just want to run tail on this SSH log and see what's happened recently, right? So just to sort of clarify that we're not learning this just for the sake of whatever, so that we can list the end of a file. There are use cases, and we're learning how to do very simple things right now, but they will all snowball and come into play as we're doing more advanced things within these systems later in the cohort. But all of those commands, cat, head, tail, man pages, sort, are all going to be covered within the workshop. There's videos for you to watch, and that'll be recapped and revisited. It's early in the cohort. I want to make sure that we're sort of making sure that everybody's on the same page before we start digging into this. We want to focus on fixing kinks within logic and understanding, not confusion about what we should be doing and where we should be doing it, right? We want to get those foundational pieces locked in. Just out of curiosity, how many groups were able to get through both exercises in the cohort connection before lunch? If not, perfectly fine. It's like a couple, almost done. Perfect. I didn't expect you to necessarily be done. Just curious to see where we're at. So we'll break into breakout rooms. We only had about an hour before lunch, but we have a few hours to work through finishing up that cohort connection and then jump into this workshop. There is a checkpoint unlocked for today as well. Don't forget to knock out that checkpoint before the end of the day. The class, by and large, did great with knocking that out, knocking yesterday's checkpoint out before today. So let's continue those good habits. It makes me happy.
Also, I just want to add before we get into rooms, if you logged out of Zoom, Zoom does not remember what room you were in. Unfortunately, neither will we most likely. So if we get broken into rooms and you don't get your room invite, pop a message in the help desk channel, just letting us know either the room number you were in or who you were with, and we'll get you sorted.
The best solution for lunch breaks is to just shut your camera and mic off and walk away. But staying logged in is helpful for organizational purposes.